Lesson 13, page 48, about common factors and finding what we call the greatest common factor. Then we'll finish off with some multiplication word problem stuff. So let's just get back to what I need here. All right. Greatest common factor, how do we abbreviate that? Right? G, C, F. We say find the GCF of a couple numbers, like find the GCF of 12 and 15. What's the first step? We got to find the factors first. Factors are numbers multiplied together to find a total, in this case 12. Well, which two numbers are always factors of a number? 1 and itself. And then we fill in the middle from there. Is 2 a factor of 12? Well, it ends in 2. Therefore, 2 times what? 6. What about 3? 2 plus 1 is 3, which is divisible by 3. So if it's divisible by 3, 3 is a factor. And 3 times what is 12? 4. And now we've got nowhere else to go because we've already done 4. It tells us we're done listing factors. Let's try 15 in red. Think in your head, what are my first two factors? Going once, going twice, 1 and its self. Did you get that? All right. What's next? Can you do this? 2? No. 5 plus 1 is 6, divisible by 3 by 2. Yes. So 3 times what? All right. Can I get any more? Not 4. And I'm already to 5, so I got this big awkward gap. But oh well. Now, we've found the factors. You got that? Now, they didn't just ask, what are the factors of 12 and 15? What'd they ask? Right? Greatest common. Well, which one do you want to start with? G or C? Why don't we work our way to the left since we've already done the F? Common factors. Let's circle in yellow any common factors. 1, common in both, right? 3, common in both, right? Any others? No. Lastly, what do we mean by this? Greatest. The biggest one that's also common. The biggest one in our yellow circle. 3. So you don't write 3 times 3, and you don't write 3 plus 3 or 3 twice. You just say 3 was a factor that was in both common, and it was the biggest, greatest. Answer 3. That's talked about on page 48, the first example. What about 24 and 7? That's example 13.1, letter B. First, you list your factors. 24 will be a lot of them. 1, 2, 3, 4, 6. Right? 8, 12, and 24. What about 7? Easy. 1 and itself. Any others? Nope. 7 is a prime number, which means we'll have a very limited list. Only common factor is going to be 1. What we say when the only greatest common factor is 1 is that the two numbers are prime to each other, which we say relatively, which means to each other, relatively prime. They are relatively prime. Why? 24 and 7 only share 1 as a common factor. They got nothing in common. 24 and 7 go out on a date. It leads nowhere. They've got nothing to talk about, nothing in common. Practically a disaster. Example 13.2 wants us to find the GCF of 72 and 90. Oh boy. These are big numbers. Remember what we do with big numbers when we're finding GCF? It's far quicker to set up what we just learned. That's why we learn it first. What are these? What am I doing? Am I losing my mind? No. Call them factor trees. Right? Okay. Oh. And 90. 9 and 10 is what I'm going to pick. 5 and 2 are prime. 3 and 3 prime. So 5, 2, 3, 3, 3, 3, 2, 2, 2. Now, we list them left to right, greatest to least. So 72 was 2 times 2 times 2 times 3 times 3. 90 is a little more. No, actually not too bad because we got a 5 in there. Oops. Let's just undo that. 2 times 3 times 3 times 5. Okay? Now, we pick out any common prime numbers. We say 2, 3, 3, nothing else. Hopefully you catch why. And finally, we multiply the ones we chose. We had a 2 in common, a 3 in common, and a 3 in common, right? These 3. Don't list them twice. What is that final answer? GCF is, oh boy, messy, 18, right? Final answer, greatest common factor, 90 and 72. We found it by using factor trees, listing those prime numbers, least to greatest, picking out what was common, and listing just the 3 numbers that are common. Not all 6 in both, but just the 3 because they're common once. You might want to save this video for later. Find it later because you're going to hit GCF problems, especially when you start hitting LCM, least common multiple problems. You're going to get them confused, especially when you have to find big ones and you have to go through a whole process. But let's do the rest here. Her score in the second game, this is a multiplication word problem. Score in the second game was the product of her first game score and 25. She scored 14,025 in the first game. How many did she score in her second game? Pause the video, read that over again, think about it for 1 minute. Go ahead. All right, if you hit play, you've had a chance to think about this. Some word problems require that numbers must be multiplied to find the answer. It's not just all addition, subtraction problems out there. These word problems sometimes contain that word product, and we know what that means, right? We've studied that. Many of them contain the word times used in a phrase like 5 times as many. In this one, we've got the word product. All right, you can read example 13.4 to see the times how many types of questions. But it's asking me if I know the score of the first game and I know the first game score as the first game score times 25, right? That product is the second game score. Guess you did a lot better on the second game, assuming you want points in whatever score and game this is. Right? It says the product is the second game score. And that product is the first game times 25. We know the first game. We need at least one known here to solve. So type in your calculator, 14,025 times 25. You get a pretty hefty number. That product, according to the word problem, is the score in the second game. We used multiplication to find a product as an answer. Answer should be 350,625 points. Why don't you pick 2 practice problems for me from page 49? Show them to me when I'm not busy, and we'll get you started on your homework today. Thank you.